Okay. Can you guys hear me okay?
Yes.
Okay, cool. So the QR code to sign in is up there, and I'll send the sign-in link again in the chat box. And then we'll get started in like a minute. Okay, so you guys should know by now that your exam tomorrow is comprehensive over the whole semester. So that's how I've made this test prep. I also, if you notice, I uploaded a final prep. We're not going to have time to do that this semester, but I went ahead and uploaded that in the key for you guys just in case you wanted to go over it, you felt like you need the extra help. But I am going to pull, like, I think the last 3 or 4 questions from that final exam prep just because I think it's helpful to this. So that's what we're going to do today. Kind of hoping it'll go by kind of quick. This shouldn't take the full 2 hours because I really just sort of want to do like a review, help jog your memory, help get you some practice. But mostly we've already gone over a lot of the stuff. Oh, I exited out of my thing, so I'll pull that up. Okay. Okay. So this is the test prep for sheet. So, sorry, let me pull up my key real quick so I can look back at it. So of the following, only blank is a chemical reaction. Is it A, tarnishing of silver, B, sublimation of carbon dioxide, C, dissolving sugar in water, D, melting of lead, or E, compression of oxygen gas? Which of these is a chemical reaction?
Is it B?
It is, okay, we have A, B, and C as answers. Answer choice is also in the chat. It is going to be B. Or no, sorry, A. I said B and then I highlighted A. It's going to be A. So sublimation is just a type of change in the state of matter, right? But it's sort of an extreme one. You're skipping a phase of matter. Okay, this is going way, way back. A wooden object has a mass of 10.782 grams and occupies a volume of 13.72 milliliters. What's the density of the object? Who remembers the density equation? I know it's from a long time ago.
Mass over volume?
Yes. So mass divided by volume. Our mass is 10.782 grams divided by 13.72 milliliters. So what is our volume, or sorry, our density?
0.786.
One more sig fig.
0.7859.
Yes. And what is the what's the unit?
Grams over milliliters?
Yes, grams per milliliter. Sorry, I'm gonna turn off my camera real quick. I need to blow my nose. If you can't tell by my voice, I'm a little bit sick. So, what is absolute zero? What does absolute zero mean?
Is that like 0 degrees Kelvin?
Yes, 0 degrees Kelvin, or 0 Kelvin, sorry. 0 Kelvin.
0 Kelvin.
Which subatomic particle is the lightest and the smallest?
Electron?
The electron. Okay, which of these species has 54 electrons? Is it A, B, C, or D?
A.
Wait, what was that? I'm sorry. Someone said an answer, but I was drinking, so I didn't hear it.
B.
It's B. So just to sort of recap, that bottom number, the top number is the isotope weight, and it's going to be the protons plus neutrons. That bottom number, or the second number, is the atomic number. That's how many protons and electrons a neutral atom has. But since we have that -2, that means we have 2 extra electrons, which would make it 54. Which of the following are chemical processes? Rusting of nail, freezing of water, decomposition of water into hydrogen and oxygen gases, compression of oxygen gases. So
Rusting
more.
is-
So if you'll look, I have these answer choices. I made this question really weird. I really regret making this question this way. But basically there's more than one.
I'm thinking either D or E.
Okay. Any other answers? Because one of those is correct. Does anyone want to take a shot? D or E? Okay, it's D. Yeah, D. So rusting of nail, decomposition of water. A certain liquid has a density of 2.67 grams per centimeters cubed. If the volume of the liquid is 30.5 milliliters, the sample would have a mass of
So this one would just be density multiplied by volume.
yeah.
So I got 81.4.
So the big part here is that 1 centimeter cube is equal to 1 milliliter. That's the big thing here. 1 centimeter cubed is equal to 1 milliliter. The gold foil experiment performed in Rutherford's lab, A, was the basis for Dalton's atomic theory. B, utilized the deflection of the beta particles by gold foil. C, proved the law of multiple proportions. D, confirmed the plum pudding model of the atom with mass spread uniformly throughout an atom. Or E, led to the discovery of the atomic nucleus, which contains the heavy subatomic particles.
E.
E. Basically, he shot these rays into a piece of gold foil, and if everything was spread out uniformly, you'd expect it to go straight through, but there were areas where it would deflect in such a way that led to the discovery of the nucleus. Okay, which formula name pair is incorrect? FeSO4 is iron 2 sulfate, FeSO3 is iron 2 sulfite, FeS is iron 2 sulfide, Fe2SO3 as iron 3 sulfite, and Fe2SO4 3 as iron sulfide.
Mm.
Okay, so we got a couple answers so far. We have A and E. It is E. What is sulfide?
Mm.
S. So if you notice, C and E have the same name listed, right? So that means that only one of those can be correct. And we said up here in A that SO4 is sulfate, right? And that one's right. So this has to be iron 3 sulfate to be correct.
Okay.
Okay. The correct name for H2SO4 is also, I'm doing my best to get the chat to pull up, but it's kind of difficult sometimes.
Is it just sulfuric acid?
It is sulfuric acid. When a hydrocarbon burns in air, what component of the air reacts? Okay, I've got the chat box. Not component of the hydrocarbon, but of what component of the air is going to react. Also, what's another way? Okay, when we're burning a hydrocarbon, we have a specific name for that type of reaction. What is it? Combustion. So in combustion, what are the two reactants?
Is it oxygen?
Oxygen, reactant. Water and carbon dioxide are products, right? The reactants are hydrocarbon and then oxygen gas. So the component of air that reacts with the hydrocarbon is oxygen gas. Okay.
A little bit more, sorry.
Yeah, so basically burning a hydrocarbon is just another way of saying combustion. And I'm working. Okay, thanks. Sorry. So where was I? Combustion of a hydrocarbon. If you were to go back and look at that sheet, you'll see that you have the like CXHY plus O2 goes to H2O and carbon dioxide. Okay. Write a balanced composition. Balanced composition. I don't like that. Write a balanced equation for the decomposition of sodium azide into sodium and nitrogen. So NaN3 goes to Na plus N2. Where do you guys want to start?
By putting it in.
Yeah, that's right, Angelica. What was it? Okay, well, so we got it right anyway, so it's gonna be 2, and 3. Okay. The combustion of propane C3H8 in the presence of excess oxygen yields carbon dioxide and water. So notice this is just this combustion equation up here, right? When 2.5 moles of oxygen gas are consumed in the reaction, blank moles of carbon dioxide are produced. So this is stoichiometry again. So I'm telling you that, sorry if you can hear my dog barking. It is dinner time for them. So C3H8 plus excess oxygen, right? So we have O2. And I told you that it yields carbon dioxide and water. Oops. So we need to balance this. This is very unbalanced. Where do you guys want to start? Okay, we can start with carbon. So we have 3 carbons on the reactant side and only 1 on the product. So we're going to come over here and put a 3. And now we have 6 oxygens, 7 oxygens, right? We need to balance those oxygens out because here we have 7, here we have 2. We need to get the product side to an even number, right? How many hydrogens do we need on that product side?
We need 8.
We need 8. So we're going to go ahead and put a 4 in front of that water. And that's going to give us 4 oxygens plus 6 oxygens, 10 oxygens. So we're going to come over here and we're going to put a 5 right here. And that is our balanced equation. Okay, what are the 2 reactants of a neutralization reaction and what are the 2 products? Neutralization. Acid and base are the reactants. What are the 2 products?
Water.
Water and salt.
Oh, yeah.
Water and salt. I know we've slept a lot since we went over this stuff. So salt meaning metal plus a non-metal. Any metal plus a non-metal is salt. And hopefully at this point you know that it's not just table salt. Okay. What is the net ionic equation for a reaction between aqueous nitric acid and aqueous sodium hydroxide? Okay, this is going back to the start of things people usually really don't like. So, check. Okay, So what's the formula for nitric acid?
Is it HNO3?
Yeah, HNO3. Ooh, and it's important to put the aqueous because we're dealing with solubility. And what's the formula for sodium hydroxide?
NaOH?
NaOH, also aqueous, goes to, what are our two products?
Would it be water and then like sodium nitrate?
Mhm. And then I think that was, Alyssa also said that in the chat. Yeah, you're both right. That's going to be water, which is liquid, and NaNO3, which is, what's this, is this soluble or insoluble?
Insoluble.
Which one was that?
Would it be a solid?
No, actually, this one is going to be aqueous. It's going to be soluble in water. I'll put a little thing at the bottom here. So how are we going to find our net ionic equation from this?
So this would just be basically the things that are making the product, right?
Mm-hmm. What's our product here?
So that would be the water and the sodium nitrate.
So yes, but our net product is going to be that water, whatever changes state of matter, right?
Okay.
So you can either do it that way or you can go the long way, and there's nothing wrong with that, which is just blowing up the whole equation. Which means if it's aqueous, you're putting it in ion form. Sorry, it's weird with those plus charges. H2O is a liquid. You can't split that up, right? You just leave it as is. So basically what this means is you're canceling out everything that shows up on both sides of the equation, and you're keeping what doesn't cancel out. So you should end up with H plus aqueous plus OH minus aqueous goes to H2O liquid. Does that make sense?
Yes.
If you want, you can try and remember this, but yeah, no, Griffin, you're right. H plus, except for the charges, but yeah, that's right. Hydrogen ion plus hydroxide ion goes to water. And that's the net ionic. The one above it, where I've like written everything out, is our complete ionic. Very rarely will you be asked to write that. Usually she just wants the net ionic. Another thing, you can write this down. You can try and remember it. But if this doesn't sound familiar, if this sounds like something new, just stick with what I've just shown you. Don't try and learn something new so close to the end, the test. The net ionic equation for an acid-base reaction is always H plus OH minus goes to water. Water's always the net product. If it doesn't sound familiar, if that's not like rejuvenating your memory, just don't even worry about it. Okay. A strong electrolyte, let me put my key for this one. Okay, a strong electrolyte is one that reacts, associates, ionizes, or disappears completely in solution. C, it ionizes completely in solution. And ionize is what happened up here. Like up in here, everything split up into its own ions in solution, right? Because that's what aqueous means in water. Which ions are spectator ions in the formation of a precipitate of silver 1 chloride via combining aqueous solutions of cobalt 2 chloride and silver 1 nitrate? Okay. So I've told you here. You know what? I actually can't remember the charge of chloride. No, chloride is just kidding. I
Would
just
it
can't.
be cobalt and the and nitrate?
Yeah. Yeah, exactly. I'll show it real quick. Basically, you know that your precipitate is silver chloride, and that means that silver is participating, and that means that chloride is participating, and that means that cobalt and nitrate are spectator, right? They're not really doing anything. A 17.5 milliliter sample of acetic acid solution required 29.6 milliliters of a 0.250 molar sodium hydroxide solution for neutralization. The concentration of the acetic acid was blank M. Where are we going to start with this? These are the ones that most people hate because this is stoichiometry, right? Chapter, I think it was chapter 4.
Do we need a balance equation?
Yeah. Well, yeah, we do. You're right. Sorry. Okay. We always want to start off with a balanced equation, and that's why I gave you the formula for acetic acid because it's really long, and I don't believe she told you to remember acetate, but she may have. Okay, what's one of our products? It's a neutralization reaction. What's one of them that's always gonna
Would it be H2O?
It's gonna be H2O. Sorry, people in the chat, you're ahead of me. And what is our other?
And this one would be a salt.
Yes. We're gonna have, oh shoot, I don't even want to do this. But basically it's gonna come out to acetate. No, water. Sodium acetate. It's going to be sodium acetate. I'm going to show you a trick here so that you don't have to tackle that beast of a molecule. If you already know it, if you know what it is, that's totally fine. If you learned it like we were meant to, basically this is a really weird way of writing acetic acid. It's that H at the end that's coming off. So it would just be NaCH3CO2. And that would be sodium acetate. Or you could look at it and you could say, hey, everything I'm dealing with over here in these reactants is a plus or minus 1, so it's all going to stay with 1 coefficient, if you already know that. If not, honestly, she would probably give acetic acid to you written this way. And I don't know why I didn't. I just didn't for some reason. Sorry. Okay, and then once you've got your balanced equation, you can go ahead and start working. So we're going to convert to moles using molarity is equal to moles divided by liters. And we need at least 2 of these factors to start working. So we're going to start with acetic acid or sodium hydroxide. What one are we going to start with?
Would it be the sodium hydroxide?
Yeah, we're going to start with that sodium hydroxide because that's what we have 2 values for, right? So our molarity is 0.250 is equal to moles, equal to moles divided by, we're given milliliters if you'll notice here, but this has to be in liters, right? What is 29.6 milliliters in liters?
Point 96.
It's going to be 0.0296 liters. And then we're going to do some math. I need to open my calculator. It's going to be 0.250 times 0.0296. And that's going to give us 0.0074 moles of NaOH. And then we go in and we do some stoichiometry. So we're starting off with this many moles of sodium hydroxide. What's going to go on the bottom?
Would it be 1 mole?
1 mole of sodium hydroxide. What's going to go on top?
Would it be like the moles of the sorry, I can't even say it.
You're good. 1 mole of acetic acid. And so how many moles of acetic acid is this going to give us?
Would be 0.0074
Yep.
moles.
0.0074 moles of acetic acid. And now we can go ahead and put that back into our, back into our molarity equation up here. So for, acetic acid, it's going to be molarity is equal to 0.0074 moles divided by 0.0175. Oh, I screwed up. I'm sorry. I'm really bad at typing. I hate doing these things online. Liters. So what's the concentration of acetic acid that we're going to get?
Is it the 0.423?
Yep, exactly. 0.423 molar is our answer. Okay, and in the chat, you guys got that as well. Awesome. Of the following, which is a state function?
I have a question about the last,
Oh.
last question.
Yeah, go for it.
I don't know if this is right, but couldn't you just do M1 V1 equals M2 V2? Because I did that and I got the same answer.
So for this particular question, it would have worked. The reason I say don't do that is if your coefficients change, it won't work. If your coefficients in that balanced equation change.
Okay, cool.
But M1V1 and M2V2 is going to work every single time for dilution problems, whenever you're talking about a concentrate and a diluent. Okay, of the following, which is a state function? Heat, Q, uppercase H, W, or none of the above? C. Uppercase H is enthalpy, which is a state function. Okay, which of the following is a statement of Hess's law? If a reaction is carried out in a series of steps, the delta H for the reaction will equal the sum of the enthalpy changes for the individual steps. The delta H for a process in the forward direction is equal in magnitude and opposite in sign to the delta H for the process in the reverse direction. If a reaction is carried out in a series of steps, the delta H for the reaction will equal the product of the enthalpy changes for the individual steps. The delta H of a reaction depends on the physical states of the reactants and products, where E, the delta H for a process in the forward direction is equal to the delta H for the process in the reverse direction. It's a lot to sort of unpack. A. Remember, Hess's law is what we're about to do, actually. So I think it's exactly what we're about to do. So if it's carried out in a series of steps, the reaction will equal the sum of the enthalpy changes for the individual steps. Yeah, we're about to do it. Okay. Delta H for the reaction is blank, given the data below. Okay. So let's just go ahead and start off with this IF5. I usually just like to start off with what's at the very beginning of my equation. I like to work left to right in my equation. So where is that IF5?
At the bottom.
It's on the bottom equation. Is it on the product or reactant side, or reactant or product side?
Would it be product?
Right, it's on the product side in that bottom equation, but I need it on my reactant side, right? So what I'm gonna do is I'm just gonna flip this. We're gonna get that IF5. Sorry, I'm not making the subscripts. It just takes a really long time for me because I'm really bad with computers. So we are just flipping this. And we also have to flip the sign, right? That's something that you can't forget. You're flipping everything. So we're going to get a positive 745 kilojoules. And after I rewrite the new equation, I personally like to just go ahead and like mark this out. I just go ahead and mark it out, because if I don't mark it out and I leave it, I'll start trying to work with it again and it ruins everything for me. Okay, so we've got our IF5 on the right side. Now we have our IF3. Where do we have IF3 in these bottom two equations?
At the top.
And the top one is on the product or reactant side?
Product.
Product, right? And that's where we need it. So it's good to go. So next up is this F2. If you'll notice, we have F2 in the top and bottom equation, right? We have it on both sides. How are we going to deal with that?
I might be wrong, but do we have to do something with subtraction?
Yeah, it's going to subtract out. So thankfully in this problem, it's already just fine. So if you'll notice, we have two F2 on this product side, and then we have one F2 on the reactant side. So it's going to sort of cancel out. it'll cancel out this F2 up here and it'll subtract one F2 from this one. So we'll be left with one F2, which is going to be up here. Does that make sense? Okay, I wish I could like write that out on like a board. So everything checks out, and then this IF up here, this cancels out with the IF and the product down here. So what is the delta H for the top reaction, the very, very top? Positive 355 kilojoules. Ooh. Yep.
If I could ask for a problem like this, I remember we had to multiply it if we were to flip it, or am I wrong?
So those are sort of separate things. It's like if it was a 2 IF5 up here, then you would have to still flip this, but then you would also multiply this all by 2.
Okay, thank you.
Okay, the energy released by combustion of 1 gram of substance is called the blank of the substance. Nutritional calorie content, specific heat, fuel value, enthalpy, or heat capacity. Okay, so we have 1 vote for. Yes, if you had a negative, if you had to multiply and flip, every time you flip, you're still going to change that sign, even if you end up having to multiply it as well. Okay. So we have a lot of different takes here. We have 1 vote for A, 1, 2 for B, 3 for B, another for C, 2 for E. It's C, it's fuel value. So specific heat. Oh shoot. I always get specific heat and heat capacity mixed up. But I remember I put this on here because this was a question on my exam and I got it wrong. I'm pretty sure I put heat capacity. Heat capacity is the amount of heat that it takes to raise the temperature of 1 gram of substance by 1 degree Celsius. Okay. The value of delta H for the reaction below is negative 72 kilojoules. Blank kilojoules of heat are released when 80.9 grams of hydrobromic acid is formed in this reaction. Okay, where are we going to start?
Balancing the equation?
Yes. So I've actually already balanced this one for you, which is pretty rare. It's pretty rare that I do that. So yeah, you would check to make sure that the equation is balanced. We check and it is, and now what? Grams to moles, right, Alyssa? So we're going to have 80.9 grams of hydrobromic acid. And what's going to go on the bottom?
1 mole. Or would it be the molar mass of the HBr?
Right, molar mass of HBr. Someone tell me what the molar mass of HBr is from the periodic table. Okay, I'll use 80.91. Is it really? Wow. I'm not playing for that time. Oh, I'm about to have to move because my laptop's about to die. Okay. And then what's gonna go on top? One mole. And what'll go on the bottom? Two moles of hydrobromic acid. And what's gonna go on top?
I believe.
What was that?
Would it be grams?
Why grams? Kilojoules. We're gonna go straight into kilojoules. So basically, this reaction is saying that for every 2 moles of hydrobromic acid that are formed, negative 72 kilojoules of heat are released. So then what would the answer to this be? Yep. It's going to be negative 36 kilojoules, or be careful with this one, because if she asked this question, you would answer 36 kilojoules of heat are released, and that's why. Because if you chose the negative 36, you'd be saying negative 36 kilojoules of kilojoules of heat are released. Okay, and then give me like 1 minute. I need to move my laptop across the room because my laptop's about to die. So just a second, just like take a minute to chill out. It's gonna take me like 1 minute. Okay, sorry. But yes, Griffin, it will be just 36 since heat is being released, and that's how our question is worded. Okay, the temperature of a 35.1 gram sample of iron increases from 24.5 degrees Celsius to 31.8 degrees Celsius. If the specific heat of iron is 0.450 joules per grams Kelvin, how many joules of heat are absorbed? What formula are we going to use here? Okay, it's a chapter 5, CMAT, yes. Q equals CM. CM delta T. This is where C is specific heat, M is mass, and delta T is just change in temperature. So we're going to end up with Q equals, our specific heat is 0.450 times 30, 5.1 times, what's 31.8 minus 24.5? 7.3. And then tell me what Q is. Or 115 joules, right? Joules. But your number is right. Okay. The wavelength of light that has a frequency of 1.66 times 10 to the 9th inverse seconds is blank. What equation are we going to use here?
I can't remember exactly, but I think it's like V under wavelength or something like that.
Okay. So we're going to have C equals wavelength times frequency. Where C is the speed of light. What's the speed of light again? Yes. 2.998 times 10 to the 8th. So here we're just going to do that. 2.998 times 10 to the 8th is equal to wavelength, so meters, I'm going to put M for meters, times 1.66 times 10 to the 9th. And what do you guys get? Yep. 0.181.
Would we divide it or multiply it?
So with this, you would divide to get x on its own, right? So just like algebra. So you would divide both sides by the 1.66 times 10 to the 9th. Nope. Okay. Of the following, blank radiation has the shortest wavelength. Is it infrared, ultraviolet, microwave, X-ray, or radio? Yes, X-ray. Okay, the photoelectric effect is, is the darkening of photographic film when exposed to an electric field, the production of current by silicon solar cells when exposed to sunlight, a relativistic effect, the total reflection of light by a metal is giving them their typical luster, or the ejection of electrons by a metal when struck with light of sufficient energy. Ugh. Okay, we have one vote for C, one for E. It is E. This is another question that I put on here because I missed it when I took the exam. Because I didn't go over the photoelectric effect at all. I thought it wasn't that important. And then it showed up on my exam. So, okay, an electron cannot have the quantum numbers of 111, 31 negative 1, 200, 21 negative 1, 321, or all of the above are valid. A, 1, 1, 1. Because L equals 1 means P, and the P block doesn't start until N equals 2, right? Okay, the mole fraction of HCl in a solution that is prepared by dissolving 25.5 grams of hydrochloric acid in 200 grams of water is blank. The density of the solution is 0.79 grams per mole. So what am I going to do? What is mole fraction? What's the formula for mole fraction? Formula for mole fraction. Maybe it's part over whole. Okay. So I want to know the mole fraction of HCl. So this is going to be the moles of HCl divided by moles of water plus moles of HCl, right? Because it's partial mole over total mole. The total solution is water plus HCl. So we are going to take our 25.5 grams of HCl, oops, and we're going to convert it to moles. I've given you the molecular weight is 36.5 grams. So how many moles does that give us? Someone tell me. Yep. 0.699. And I didn't give it to you here. You'd have to go to your periodic table to find it. But 200 grams of water. The molecular weight is 18.02. And someone tell me how many moles that is. $11.1. Yep. Okay, so this means that our partial mole is 0.699, and our total mole is 11.1 plus 0.699.
How do we establish which one's the partial and which one is the total?
Okay, that's a good question. So because it's, yeah, no, that's a good question. So this, you know that it's asking for, you know that your partial is HCl because it's asking you for the mole fraction of HCl. So this is one reason that I really like taking exams in person, because normally that's something that I would highlight or underline, because if you guys have ever had like a tutoring session with me, or I don't know, I've helped you on one problem, I'll typically tell you to underline things and circle things in the problem, because chemistry problems can get really messy and all over the place. And if you've highlighted exactly what your end goal is, it's easier to not get lost. Or if you're taking it online and you're working on a scrap sheet of paper, I typically recommend writing goal, mole fraction of HCl. So that way you can keep looking back at that and you know exactly what your end goal is. So what is our mole fraction? Yep. So for this one, I did end up using 3 sig figs, but yeah, 0.0592. Right. Okay. The predominant intermolecular force in calcium bromide is honestly, I'm pretty sure I meant to say intramolecular. So I'm just going to change that. The predominant intramolecular force in calcium bromide is not covalent. Ionic bonding, yes, because this is a metal plus a nonmetal, right? Okay, hydrogen bonding is only present when which elements are bonded to hydrogen?
Be fluorine, oxygen, and nitrogen.
Yep, on FO, fluorine, oxygen, and nitrogen. C4H10 molecules are held together by what forces? What intermolecular forces? Dispersion, exactly. Everything has dispersion forces. So if it doesn't have anything special like dipole-dipole or hydrogen bonding, then it's just dispersion.
If I could ask, how will we know which type of molecules are held together?
Okay, I will answer that right after question number 33, because one thing I've noticed is a lot of students are struggling with, how do I know if something is dipole-dipole? So I'll actually go over that right after this last question.
Okay, thank you.
What is viscosity? And I know I put this one on here. Yes, it's the resistance to flow. I put this one on here because truthfully, I did not know what viscosity was until I got into OChem. And it really messed me up in Chem 2. So you guys need to know this. Viscosity is the resistance to flow. Okay. And let me go ahead and, oh wow, there's a lot more people in here than when we started. There's a sign-in sheet. I do have the answer key up already, yeah. So I'm going to go over, how do I know something is dipole-dipole? And yeah, because it's actually a question I've been asked a lot. So dipole-dipole is going to happen with our polar bonds. So keep in mind that a molecule can overall be nonpolar, but still have polar bonds in it. Okay. So our polar bond, let's just go ahead and do CH. I'm just gonna do a bunch of CH. So this is a polar bond, like I said. Which element is going to have the partial negative charge?
It'd be carbon.
Carbon's going to have our partial negative. right? So the symbol that I'm about to draw, it's just a lowercase delta. All it means is partial negative. So that means that hydrogen has to have a partial positive. And this is going to be true for all of these, right? So what do we know about positives and negatives? How do they interact with each other? Yes, opposites attract. So our positives and negatives are going to be attracted to each other, and this attraction is what holds them together. That's true all the way down. Does that make sense? So for dipole-dipole to occur, there has to be a polar bond. Now, this would still be true if it were like CH, oh God, I meant to do that in black. If it were CH4, because overall CH4 is a non-polar molecule, right? But those CH bonds are still polar. They just cancel each other out overall. But there's still that partial negative and partial positive. So there's still going to be that attraction. Does that make sense? And then hydrogen bonding is dipole-dipole. It's just a special type of dipole-dipole. So if we have water molecules, so one thing that you learn in biology is that water is polar, and that's really important. So I'll just draw two water molecules. Here, which element has the partial negative charge?
Oxygen.
So these are partial, the H's are partial positive, and the oxygen is partial negative. So all this means is that this positive is attracted to this negative, and that's how water sticks together. So this is hydrogen bonding, and as you can see, it's just a type of dipole-dipole. Okay, and then I had some things from like 2 or 3 questions from that final study prep that I uploaded that I wanted to cover. Oh, I also wanted to say that everything has London dispersion forces. Everything has London dispersion forces. Okay. Yeah, so it's just the last 4 questions of the final study prep, and that's it. Okay. An ideal gas differs from a real gas in that the molecule of an ideal gas, have no attraction for one another, have appreciable molecular volumes, have an average molecular mass, have a molecular weight of 0, or have no kinetic energy. Okay, we have a vote for E. Any other guesses? Okay, so our answer is actually A, have no attraction for one another. So remember a few minutes ago I said that everything has London dispersion forces. That means everything has some type of attraction to something else, everything. It's really weak, it's not strong, but it exists between everything. Well, that kind of screws up things in an ideal world. Ideally, everything is neutral. Okay, 30. When NaCl dissolves in water, aqueous Na and aqueous Cl ions result. The force of attraction between Na plus in H2O is called a blank interaction. It's the ion-ion, London dispersion force, hydrogen bonding, ion dipole, or dipole-dipole. D, ion dipole. So this is another type of dipole interaction. And really it's just saying, hey, here's this ion, and it's interacting with the O dipole, that partial negative dipole charge. What does the phrase like dissolves like mean? Like dissolves like. Did you guys talk about that? Have you guys done chapter 11 yet?
No.
Okay, that's why. Okay, well, I'll give you guys the answers to these so that hopefully when you do go over it and this is on your final, you'll know it. So basically this means polar solvents dissolve polar solutes. And nonpolar solvents dissolve nonpolar solutes. Also, I just want to say there's an entire lab in OChem that revolves around this concept. So really, if you do have to go to upper level chemistries, I suggest you keep your notes and you keep your exams, because the stuff is going to come back. You like have not thought about it in a year, and then it's like, oh, you have an entire lab assignment over this. So definitely keep up with it. And then in a saturated solution of a salt and water, the rate of crystallization is equal to the rate of dissolution. And again, I do have the answer key for this posted, so you can go back and visit it, of course, once you guys do cover chapter 11. Okay, cool. So are there any questions? Okay, then you guys are free to go. Good luck on your exam. And this is last SI, but all of my stuff is still up on my website. So good luck, guys. Okay, Damien, you had a question. What's up? You can message it to me privately if you want. Number 2. On the test prep? Or on the, yeah, on the test prep 4? Okay, that's cool. I'll go back to that. Okay. Okay. Yes, what about it? So this is a density problem. So this is just density is equal to mass divided by volume. And yeah, you're just taking the mass and the volume and dividing. That's all. Okay, does anyone else have any questions over something on here? Is that all? Okay. 1 second. I know I just sent it to you, Amber. I'll keep an eye out for anything. I'm currently stuck at home, so if my boss does call me, it will be over the phone, so and not in person. So I will send out a picture of the final study prep flyer. Oh, I can stop recording this.